Today is the 14th of September 2023, and this will be our second lesson on sequences. We started introducing sequences yesterday. Before I start the lesson, thank you to everyone who has been watching our videos. Okay, please, can you consider subscribing, sharing, liking, and following us? Okay, depending on which platform you are using to watch, and if it is helping you, it's likely to help somebody else. Okay, so just share it so that it can help other people as well. Thank you very much. I normally write, please follow my notes/script, okay? Because I normally watch the video before I upload, and then when I finish, I watch it to see how it come across. Okay, so for instance, this is 2A add 4C. So if I say 2C add 4A, no, because what I'll be solving will be 2A add 4C. So what my pen is pointing to is what I'll be explaining at a particular moment. So please follow the notes. Okay, if I find out that there's something wrong with the note, I'll come and correct it in the next video, or I would just say it. But so far as it is with this platform, watch, listen, but follow my notes and script, because it will help you a lot. Please don't assume as well. Beware of these people. Okay, every opportunity, scammers, they will use it to get money off you. Okay, so if you are online, beware. I'll not be asking you to donate money to charity, to orphanage, to whatever they make up. Please don't fall for it. Okay, if I have something to say, it will be in the video like I'm saying it now. Okay, but if I haven't said it, don't just think, oh, they are, no. If I haven't said it in the video, it's not me, and I wouldn't ask for donation. Okay, so please don't fall for scammers. Okay, now I'll recap from last lesson. We introduced sequence and pattern of numbers. Okay, and then we saw a first term, and the difference in terms make every sequence unique. So we saw sequences, they might have the same numbers, but the first term is different. And so even though they have the same difference, okay, or maybe it's they have the same numbers, the first term is different, the rule is different. So every sequence in that sense is unique. So for example, 2, 7, 12, 17. Okay, the first term here is 2, and it's an increment of 5. So 2, 7, 12, 17. So the rule here is plus 5. And this is an infinite because it goes on and on. It doesn't end. So we use 3 dots to denote that. And you separate each number by a comma. Okay, it's an infinite. It doesn't end. Okay. And then the second sequence, if you look at it, it's the same numbers. Okay, 17, 12, 7, 2. But it's a different sequence because the first number here is 17. Okay, the difference here is decrease of 5. Okay, so it's the rule is minus 5. So the fact that they have the same numbers doesn't make it as the same sequence. Okay, the sequence are different because of the first term and the rule that generates the sequence. Now, because this sequence ends as 12, okay, there is no comma after, ends at 2, sorry. There is no comma after 2, so this is a finite sequence. Okay, it stops. And if finite doesn't end, that is the where we get the word infinity. It goes on and on and on. You can sit here for 1 week and keep on adding 5. It's not going to end. After the largest number, you can still add 5. Okay. Now, consecutive terms are next to each other. So, like the first 3 terms are consecutive terms. Okay. The last 3 terms are consecutive terms. Okay. The second, third, fourth terms are consecutive terms. So 2, 7, 12 from this sequence are consecutive terms. This is what we did yesterday, so I'm just recapping. 17, 12, 7 are consecutive terms. Okay. So I think this is what we did yesterday. Okay. Now, our starter for today, because we have a lot to do, I just wanted to bring in something simple. So, let A equals 1, B equals 4, C equals 9. Now, what is 2A add 4? So, A is 1. So, 2 times 1 is 2. C is 9. So 4 times C is 36. So 2 add 36 is 38. So this is a way of substitution. Okay. We've seen this several times. The chances are, if you are doing a higher paper, you have learned, you have mastered this. But somebody even doing the foundation paper might be struggling. So that's at times I bring in starters that are easier, so that maybe if you're on the foundation level and you are still trying to figure this out, you can just have something to go away with. Now 8C, C is 9. So 8 times C, 8 times 9. A is 1, so 3 times 1. Okay, so 8 times 9 is 72 minus, okay, 3 times 1 is 3, so your answer will be 69. B squared, so 4 squared is here, A squared is 1. So 4 squared minus 1 squared is 16 minus 1. 1 squared is 1. Okay. So that will be 15. 7b. B is 4. So 7 times 4 is here 28. Minus a, 1. So 28 minus 1 is 27. Okay, so that will be our starter for today. Okay, so if you've forgotten, this is just to help you a little bit. So today, sequences have rules. We've seen it yesterday. Okay, some of them are straightforward. So plus 2, add 2, minus 2, add 3. They are just straightforward. Okay. Example, add 5. So 5, 10, 15, 20, and it continues. It's infinite. That's why we have these 3 dots. If it stops, if it terminates, there'll be no 3 dots, but it continues, and we separate each number by a comma. Some are random. So for instance, if you pick a name from a hat, or how the lottery people do it, they just pick a ticket. That is random. But here, we are considering sequences of numbers with a rule. It's not a random thing we are doing like the lottery. So we are looking at numbers which have a rule, which have a first term, so that we can deduce like the 100th term from the rule. Okay, so if it's add 3, then we are going to continue adding 3. But at some point, we have to find out how we can deduce a rule to be able to, because you can't sit down and be adding 3 till you get to the 100th term. Okay, there should be a rule. Okay, so we'll be talking about that. So example, 10, 20, 30, 40, 50. So this is addition of 10, or the 10 times table, or we can say the multiples of 10. Okay, or add 10. So if I have 2, it's not in the note, 2, 4, 6, 8, 10. These are multiples of 2, or we are adding 2. Okay, if I have 6, 12, 18, 24, 30, these are multiples of 6. Okay, or add 6. Okay, so these are the rules, so you can see it and see, but these are straightforward. Okay, what you subtract or add to deduce the next term is the rule. So if you are going to add, okay, a certain number, whatever you add is the rule. So for instance, here we are adding 10. So the first term is 10. To get the second term, you have to add 10. Is that okay? To get the next term, so the rule here is add. So let's look at some examples. Okay, so here the rule is add 6. So 14 add 6, 20. Add 6, 26. Add 6, 32. Add 6, 38. So our rule here is add 6. 140 minus 18 is 122. Minus 18 is 104. You can pause and check on your calculator, or you can do it. It's minus 18. 104 minus 18 is 86. 86 minus 18 is 68. So the rule here is minus 18. The first term, second term, third term, fourth term, fifth term. Now here, our first term is 2, our next term is 6. So here is times 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 126. All these terms, because there are 3 dots, they are called infinite. They don't terminate. Okay? If they are not finite, it stops. But this one can go on and on and on. So the rule here is times 3. 20 minus 12, you get 8. 8 minus 12 minus 4. Minus 4 minus 12. You remember when we're working with negative integers. Minus 16. Minus 16 minus 12 minus 28. So the rule here is minus 12. Okay. Now, so you can be asked to find the missing numbers in a sequence. So you deduce the rule, and then they'll give you a set of numbers, and then you'll be able to find the rule to find the missing numbers. So for instance, I've put the bar under the missing numbers and I found it. The rule here is minus 9. Okay, so you were given 62, 53. Okay, and then 44, then 35, 26, and then there is a dash dash. Okay, so minus 9 to 53. So if I subtract minus 9, I'll get 44. So that's my first missing number here. Minus 9, 35. Minus 9, 26. Minus 9 again, 70. So that's my second missing number. Minus 9 is 8. So my missing number for this sequence will be 44, 17, and 8. So these are the missing numbers here. 44, 17, and 8. Okay, so you can be given a sequence, and then you'll be asked to find the missing numbers. Okay, now another example of that. So you have 12. Okay, when you add and then there's a missing number, then you have 34, 45. So because I don't know this, what would I do to 34 to get 45? I add 11. Okay, so if I add 11 to 12, I'll get 23. And if I add 11 to 23, I'll get 34. So straight away, my rule is add 11. Then if I add 11 to 34, I get 45. So I found 23, I found 45, add 11, 56. Okay, add 11, 67. So the rule here is add 11, and my missing numbers are 23, 45, 56. So there you go. Okay. In the exam, you just write it in the bar. Okay, but I wanted to show you how I found the missing numbers. Okay, you can determine the formula for any term. Okay, we are going to get to that. Okay, so for instance, this is the first term, the second term. Okay, so here n equals 1. Second term, n will be equal to 2. Third term, n will be equal to 3. Okay, so if I'm going to use their position, like n equals 1, to find the rule of a sequence, okay, or to find the pattern, that will be called the position to term rule. Okay, these ones that we've done so far, they are short sequences, so we can see. But what if we can see? How? And then what if we are supposed to find the 100th term? We can't see the forever adding and subtracting. We should be able to use the first term, deduce the first few terms, deduce the rule and the pattern, and then find the 200th term. Okay, with the formula we've made up, and that is called the position to term rule. Okay, we'll do a lot of examples on that tomorrow. Okay, but I wanted to introduce you to that today. So for instance, if n equals 1, that will be the first term. Okay, the first term is not the number. The first term is a number, but n equals to 1 is its position. That's why we say the position to term. So this is the first, n equals 1. This is the second, n equals 2. This is the third, n equals 3. And this is the fourth, n equals 4. So we can find maybe what is the value of the sequence when n is 100 or when n is 1000. We don't have to be adding and adding and adding. Okay, so if you look at this, okay, I have deduced the rule, and I've said it's 3n minus 1. So when n is 1, 3n is 3 times 1 minus 1, which is 2. Okay, today's starter will be handy. What we did. So 3n, n is 1, first term, which would be 3 times 1, 3, minus 1, which is 3 minus 1, 2. So that will be the first term. But we need to make sure that it is suitable for the other 2 or other 3. Because we might apply the rule to the second, the third term, and it will not be right. So let's see. If n is 2, the second term, so 3 times 2, okay, will be 6 minus 1 is 5. So that's why we have 5 here. Okay, if n is 3, okay, so 3 times 3 is 9, minus 1 is 8. That will be the third term. If n is 4, there 3 times 4 is 12 minus 1 is 11. So that will be 11. So what if n is 10? That will be the 10th term. So we found 1, 2, 3, 4. So if n is 10, 3 times 10 is 30 minus 1 is 29. So straight away, that will be our 10th term. And then we can find what if n is 100. That will be 100th term. So we don't need to be adding 3's. So if n is 300, 3 times 100 will be 300 minus 1. So will be 299. So that will be 100 term for this sequence. So straight away, our rule is 3n minus 1. That is called the position to term rule. Okay, we'll do a lot of examples on that tomorrow. Now, I want to show you there are 2 types of sequences. We have the linear sequence and then we have the quadratic sequence. Okay, we have the linear sequence and the quadratic sequence. I want you to go away and do look at again the position to term rule, because we'll be looking at it to see how we deduce, because the formula you use 3n minus 1, so that will be our rule here using the term. Okay, so even this, we can find the thousandth term. If n is 100, we put it in the equation and we found the 1,000. You don't have to be adding and adding like we were doing before. Okay, but the rule will also be different for each sequence, as we've seen earlier. So it's not just one rule here, but the sequence will show us what rule and what pattern is and what order is going. We'll use that to help us find the rule in this order. Okay, where n is the position to term. So n will be 1 the first term, or the 50th term, or the 1500th term. Okay, now as I said, we'll look at examples. Okay, there are 2 types of sequences: linear sequences and quadratic sequences. Now with linear sequences, they come in 2 types. The linear one, when it is adding or subtracting, is called the arithmetic progression. Okay, so we're saying plus 5 minus 5. So this is the first term. You add 5, you get 8. So this is a linear sequence, but it is adding. This is also a linear sequence, but it's subtracting. So if it's a linear sequence, it's either adding or subtracting. Okay, so the rule will be add something or subtract something. If it's a geometric sequence, so it will be times or divide. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So here is multiplying and it's a geometric sequence or geometric progression type of sequence. Divide 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Okay? So, if it's multiplying or dividing, then it becomes a geometric progression. But arithmetic and geometric progression, they are all under linear sequences. Okay? Which we've seen today. But there's another type of sequence, the quadratic one, where you have like n squared, 3n squared, 5n squared. So for instance, the first term here is n is 1. So 1 squared is 1. Second term is 2. 2 squared is 4. Third term is 3. 3 squared is 9. Fourth term here is 4. 4 squared is what? 16. So you can go on and on. So this is the first 4 term. So we can find the 50th term. All we need to do is 50 squared. And then we've got it. So our rule will be n squared. So any rule that has to the power 2 is called quadratic. Okay, it's called quadratic. It's another type of sequence. Now here you can have 3n squared. So if these are the n squared, so if I multiply by 3, so the first term is 1. And 1 squared is 1 times 3 is 3. Okay, so it's the same sequence here, but I multiply by 3. So my rule here is 3n squared. This is also a quadratic sequence. Okay, so now the rule here is 3n squared. Okay, now if I take away 1, it becomes 3n squared minus 1. So 3 minus 1, okay, is 2. 12 minus 1 is 11. So if n is 1, 1 squared is 1 times 3 is 3 minus 1 is 2. Okay, you can try it for the rest. It's 3n squared. So the rule here, so anytime you have n to the power 2, okay, that will be a quadratic sequence. So our next lesson, we will use it to find the rule. We'll find the position to term rule, okay, to find it so that we don't have to be adding all day, because in exams you don't have time to add. You need to find a way of deducing these formulas, whether it's a quadratic sequence or an arithmetic progression. These ones are straightforward to find. Okay, but what if you have something like this? How will you deduce it? Okay, so so far we've recapped on the sequences yesterday, and we did a bit of a starter, and then I've tried to introduce you to the position to term rule, and I've done some examples with you. Okay, thank you so much for watching today's lesson, and I'll see you tomorrow.